Relationships can be described with an equation that connects two variables. It can be described with a table of values that connect the two variables, or it can be described as a pattern in the XY graph that connects the X and Y values on the different axes. So here we've been given the equation. We need to come up with the table and graph. Well, we can do that by just plugging in some values. Now, one thing I would recommend that you do is make it into a y equals equation, or the dependent variable equals something. So in this case here, I'm going to just add y to both sides. So I get y equals, and then it's going to stay 3x plus 4. Be careful with this. Make sure you keep track of your positive and negatives. You can balance your equation if you like to do it that way. But I've now written it as a y equals equation. Now I can plug in values to calculate coordinates. When I have an empty table like this, I could really choose whatever I want. And if the person next to me chooses different values, we're still going to get the same relationship, which is essentially the pattern in the table, in the graph. When we graph these, I would like you to get in the habit of graphing x is 0, the starting amount. When x is 0, y is 4. The other coordinates really don't matter, but we want to keep them on the grid, so I'm going to maybe have negative 3. Negative 3 times 3 is negative 9, plus 4 is negative 5. So I'm going to go negative 3, negative 5 right there. Okay, 0, 4 is right about there. Looks like I'm going to, my line is going to kind of go shooting off if I'm not careful. So I'm just going to maybe do 1, x is 1, y is 7, and x is 2, y is 10. I don't necessarily need that next coordinate. Okay, so y is 7, and that next coordinate happens to even go off. So it's going to be a good reference, but it's off my grid, and that's okay. So I can always scale my grid if I really wanted to. So the pattern I'm looking for are these straight line patterns. Okay, so that's definitely a straight line pattern. I'm going to draw it past the first and last dots because I want the whole pattern. What we've been talking about, and this is maybe not so much for this unit, but for the next upcoming unit, we've been talking about this change, this ratio of change. Plus 3 plus 9 plus 1 plus 3. We have a change in y to change in x. It is a 3 to 1 change. And we can see that as a slope. 1 plus 1 plus 3. I should really put plus, okay, because the direction is important. And that ratio of change seems to be showing up in the equation as well. So what we're really going to focus on is this idea that this ratio of change shows up as this multiplier, as a ratio of change on the outside of the table, as a slope on the graph. Okay, but again, that's more for next unit. Really what I want you to do for this up to now, we're just focusing on finding the relation, using the relation equation to come up with points and draw the graph. So again, same thing here. We want to have our 0 coordinate. When x is 0, y is 2. Maybe I'm going to try negative 4. Negative 4, half of negative 4 minus 2 is negative 4. So I'm going to start plotting these points. 0, negative 2 is right there. Okay. Maybe I'll choose even numbers because even numbers will work nicer with a divide by 2. So 1/2 times 2 is 1. Minus 2 is negative 1. So 2, negative 1. Okay. Again, make sure you get your x's and y's in the correct order. The first number is horizontal. The second number is vertical. Lots of people mix that up, but you need to make sure you have lots of practice so that you're not mixing that up. And I'll put one more coordinate in here. Let's go 6. X is 6. Y is 1. So 6 and 1. There it is. It looks like a straight line pattern, so I'm just going to draw my pattern through those points. Again, I'm going to go past the first and last points because I want that whole pattern. So the ratio of change, here is, I'll do this in green. When I compare the ratio of change, here is +2, +4, +2 here, +1 here. The change in y compared to the change in x looks like +1 to +2, or as a unit rate, 0.5 to 1. And notice that ratio of change again seems to be showing up as a slope here. It shows up on the outside of the table, and it's seemingly to do with that multiplier there.